So, black holes, they are cosmic traps. Once something falls in, nothing, literal nothing, not even light can escape it. The craziest part, they have escape velocities faster than the speed of light, the speed limit of the universe. Leave the objects with mass, it even attracts massless things going at the speed of light. Well, black holes are just insane. So we're gonna look at, well, how they form, what they are, and what gravity actually means. So the first thing is like, how the hell does massless things get attracted? As we've seen in the formula of gravitational force, that we need to have two objects to experience a gravitational force between them. If something has zero mass, then there's zero gravitational force. So how can black hole attract light and pull it like there's a force? Well, actually, it doesn't. Einstein proposed in his general theory of relativity that mass curves the fabric of space-time around it, like the Earth, and hence we feel a gravitational force, while there isn't. All of this gravity that we feel, like literally everything is just the curvature of the space and time. So it turns out that gravity isn't some force pulling objects together, like Newtonian physics first suggested. It's actually the bending of space-time around massive objects, because mass curves the space and time around it. And there's a very famous saying about it: matter tells space-time how to curve, and space-time tells matter how to move. And this was insane. Like, it told so much about the universe later. Time slowing down gravity because space and time both are affected because of mass, and accordingly, the gravity that we experience here on Earth, here it is, all this gravity, this is just because of the curvature of space-time, and there's actually no force between us. There's a curved space-time, and there was something about geodesics. Well, I don't really know. It was like straight paths on a curved, like, it's like we are moving in a straight line on a curved surface. So we think that it's actually a curved path. Like, for example, you are traveling on Earth. You feel that it's a straight path, right? But it's actually curved. Like, it's kind of the same thing. I'm not really sure about it, first of all. It just came into my mind. So the next thing is, the heavier something is, the more the space-time bends. And a black hole, it's like poking a hole so deep that the fabric rips, like the singularity. All of the mass of the black hole is confined at an infinitely small point, which is said to be the singularity. We are not even sure about if it's an infinitely dense point. Like, our physics break down there. And the area around the black hole, which we call the radius, which is the Schwarzschild radius. Now, that is the part where the escape velocity is equal to the speed of light, because at that point not even light can escape from it. Like, here's the black hole, here's the infinitely small point, here's the black hole around it. So that radius, that distance from the center, that's actually just the part where the escape velocity is equal to the speed of light, so that even light cannot escape it once it crosses that barrier. And that boundary is also called the event horizon. That's the point of no return. Not even infinite amount of force can pull you out of that. And as no light escapes from it, it's almost perfectly black body. We're still not sure if it's 100%, because as we know, like, there's Hawking radiation from it, which are the photons conserving the momentum. So there are some particles which are coming out of the black hole because they have to conserve the momentum, and that's the Hawking radiation. That's an extremely slow process. The Schwarzschild radius is 2 gm by c squared. C is the speed of light. So the speed of light squared. G is the gravitational constant, which is 6.67 times 10 to the negative 11 Newton meter squared per kilogram squared. And c is the speed of light. So 2 gm over velocity of light squared. M is just the mass of the object. So if you were to confine all of this entire planet Earth into a black hole, then the Schwarzschild radius, which is the black part of the black hole, like, or you can say just that's the black hole, that would be just